Gauss theorem. This is a very important theorem to solve the problems. This theorem is explained by the scientist. His name is Gauss. He was explained two theorems. One theorem is in electrostatics, means this chapter, and explain another theorem in magnetostatics, that is the 8th chapter in our syllabus. Now, Gauss theorem. And next, what is the significance of the Gauss theorem? This is one of the important questions for examination point of view under 4 marks. Now, first we will discuss about what is the Gauss theorem. After that, the significance. It is also called importance of the Gauss theorem. Now, let us see what is the Gauss theorem. Now, see that on the board, Gauss theorem. Now, total electric flux. What is the symbol for flux? Phi. Total electric flux over a closed surface. Total electric flux over a closed surface is equal to 1 by epsilon naught times the total charge surrounded by an enclosure. This is the statement of the Gauss theorem. Again, total electric flux over a closed surface is equal to 1 by epsilon naught times the total charge. What is the symbol for charge? Q, surrounded by an enclosure. It is a statement. What is the mathematical form? Phi is equal to Q by epsilon naught. You must multiply these two, Q into 1 by 4 pi epsilon naught. So, mathematical form is phi is equal to Q by epsilon naught. We know that in the last class we have studied the flux equation. Flux is equal to closed integral E bar dot ds. So, how we can write the flux? Phi is equal to closed integral E bar dot ds is equal to Q by epsilon naught. Means Gauss theorem mathematical form is this, and we can express like this also. Now, you have followed what is the statement of this theorem. Now, let us see. Electric flux. Electric flux means number of electric lines of forces over a closed surface. Over a closed surface. Now, let us see, this is one object. This is a closed surface. It is also closed surface. It is also closed surface. So, totally now it has how many closed surface? 1, 2, 3, 4, 5, 6. This is one shape. It has a symmetric shape. It is parallel piped. So, now this is a closed surface. The flux over a closed surface. Flux means number of electric lines of forces. Okay, number of electric lines of forces are like this, or like this, or like this. The total electric flux over a closed surface is equal to 1 by epsilon naught times the total charge Q surrounded by an enclosure. Now, let us take this is one object. If any charge Q exists inside the charge, exists inside this object, otherwise it is also one closed object or closed surface. Now, let us take here one charge is there. You take positive charge. Electric lines of forces moves in this side, in this side, in this side, in this side. In all sides, electric lines are moves. But the charge is here. Electric lines are in all sides. This charge is multiplied by, here the charge is there, this charge is multiplied by how much? 1 by epsilon naught is equal to how much? Flux. Means electric lines are in this side? Yes. In this side? Yes. In this side? Yes. In this side? Yes. When the charge is here, electric lines are all sides. That's why the total charge Q surrounded by an enclosure. Surrounded by an enclosure. So are you followed? Here charge is there. Electric lines are ejected. This charge multiplied by epsilon naught is called flux. Now you take this is another object. I am shown. Inside that is there charge, that is also spreads. Electric lines are spreads in all sides. For that purpose, this theorem is explained by the scientist Gauss. Okay, what is the significance or importance? What is significance? This law is used to find electric field of any shape or any size. This is one shape. This is one shape. This piece of chalk has another shape. Now let us take my face like this. It is also one shape. You take any shape or imagine like this is the shape. Imagine the shape is like this, just like any stone. Inside the charge is there. We can find the electric field. That's why this law is used to find electric field of any shape and size of the object without the matter. It has matter. Matter means it has the mass. It also has the mass. It also has the mass. But you take, imagine like this. Is there any matter? No. That's why without the matter, with matter, both, we can find intensity of electric field or simply electric field. This is the first importance, first significance. What is the next one? This law is to find, electric field of symmetric objects. It is a symmetric object. It is symmetric. Symmetric means we know its a shape. It is a symmetric object. Cylinder. Now let us take, imagine my face like a spherical shape. It is a symmetric shape. If take symmetric means it has one specified shape. We know that, just like a sphere, just like a cylinder or hemisphere. Hemisphere means half of the sphere. Let us take a lemon, cut it, we can get hemispherical shape. Otherwise ball, cut it middle, we can get hemispherical shape or cylindrical shape. Or you take any shape, but it has one name, that is called symmetric objects. For that objects also we can find intensity of electric field if the matter is exist or may not be. Matter may be exist or may not be. For that purpose, this theorem we can use. Okay, this is the significance of this law. See this and write your notes. See that. Now, based on the Gauss theorem, we have 3 continuous topics in this chapter to find the electric field or intensity of electric field, that are: number 1, electric field by charged rod. Next, electric field by charged sheet. Next, electric field by charged sphere. Otherwise, electric field by charged or uniform charged wire. Electric field by uniform charged sheet and electric field by uniform charged sphere. First one is electric field by uniform charged rod. Next, uniform charged sheet and uniform charged sphere.